Hello everyone, welcome back to my channel CPP Lead Rush. Today we will be solving the problem longest binary sequence less than or equal to k. In this we are given a string s. In fact it is a binary string which will consist of only zeros and ones and a positive integer k, which in this example is given equal to 5. We are supposed to return the longest subsequence of s that makes up a binary number less than or equal to k. Now, this means we will have to know the concept of number system, that 2 raised to the power 0, this is 1, this is 2, then the next one is 4, then 8, and so on. Note, the subsequence can contain leading zeros. Leading zeros means if I take this subsequence, the underlined one, 00, 1, 0, 1, then this sequence means what? Two leading zeros. Leading means at the beginning we are having zeros. It can be taken as like this also, 00, then 0, then 1. So these are what leading zeros. The zeros which are at the beginning of any subsequence. Subsequence is nothing but a string. We can remove, that is, we can delete any of the particular character in that string from the middle, but these are supposed to be in the same order without changing the order of the remaining characters. And if there is an empty string, then it will be considered equal to 0. Now, let's see this example which is given to us and understand what we are supposed to return. In this, we are supposed to return the longest binary subsequence. Now, we observe that firstly, it consists of only zeros and ones. So, if I want the longest sequence, then if I take all the zeros, it will not cause any harm to me. I will start from the right hand side and I see that I first take the 0. My length is now 1, but my sum is still 0. Now, we have to keep the sum what? Less than equal to this k. Then I move next. Next element is 1. If I add it to my sum, it is still what? It is less than equal to k. So I keep it. My length now becomes 2. 0 causes no issue. It will be directly added. Now the next one. This one. 2 raised to the power 3. This is 8. If I add it to current 2, this was 2. The sum was previously 2. If I now add it, it will become what? It will become 10, which is greater than 5, which will violate my condition. So I will subtract back this value and it will again become 2, and I will not take this one. I will move to the next value. If it is 0, I will take it. If it is 1, I will skip it. So I take the 0. Next is also 0. I take it. Now next one is 1. I will reject this one also, because since this one was leading to a larger value than k, so definitely this one will also lead to a larger value than this k. So my longest binary subsequence is this, which is of length 3 plus 2, that is 5, and this is my answer. Similarly, if I look at the second example, this time I will be properly maintaining some variables. A is the answer, which stores the length, current length, and the length to be returned, that is this 6, length of the longest subsequence. J will track this power, 2 raised to the power 0, 2 raised to the power 1, that is what is to be added, final sum. Sum will be here, this 0, 1, 2, 3, this will be stored in J. Initially answer is 0, J is 0, and sum is also 0. What is this? St means stop. I have taken a variable stop, which is a boolean variable, which checks if we can continue taking more ones or not. Initially this is also set to 0, which means no, we don't need to stop. 0 means false, and this means that we don't need to stop. Now I'll start iterating from the right hand side. First I will take this 1, so my length will become 1 now. J becomes 1, and my sum also becomes 1, because 2 raised to the power 0 is nothing but 1. Next is 0. It will cause no issue because it will not increase my sum, but the plus point is it will increase the length, because I want the longest subsequence. So my length becomes 2 and my j also becomes 2. Now same for the next 0 also, my length becomes 3, my answer that is becomes 3, and j also becomes 3. Now when I move to this next one, what does it become? It becomes nothing but what? 2 raised to the power, this is what? 2 raised to the power 3, that is 8. If I add this 8 to this sum, it becomes what? It becomes 9, but this 9 is greater than this 1. So what I do, I will mark this stop as 1, that is yes, it is true now, and I need to stop. What I need to stop? I need to stop taking these ones from the further sequence or the further binary string. And then what I need to do, I need to decrement this value that I now added. I added the value 8. So if I decrement 8, it will become again 1. So I reject this one. Next I move, it's a 0. Yes, I can take it. So my length becomes what now? it becomes 4. And j also becomes what? 4. Now, can I take this one? No, I cannot take this one since my stop variable is now what? It's true. So I'll skip it. Now I will take the 0 or not? Yes, I can because it does not cause any effect on my sum. So my length becomes 5 now and my j becomes 5 now. And I can take the last 0 also. So the total length becomes 6 and my j becomes 6. Now one point is why we need to just track it. Since we are taking, what we are doing is we are storing everything in int and 2 raised to the power 31 minus 1. This is the max value of integer. So this j should be what? This j should be less than 31. Now let's code it out. When we try to code it, we will just initialize the variables first. My j will be is equal to 0, answer is equal to 0, and sum is equal to 0 initially. Okay, and my boolean variable stop will be false initially, that is it will be 0. Now I will start traversing from the back, that is for int I is equal to s dot size minus 1. Why minus 1? We take minus 1 because the last element, the very last element is n minus 1. I will be greater than equal to 0 and I will be decremented. Now we check if the string element is 0. If the string element is 0. So string element is what? It is a character, so it needs to be in single inverted commas. That is an important point to be noticed. Then if it is yes, then we will increment the answer length. Then the next condition is else if. We will not say if it is 1. We will first check if the stop variable is equal to 0 and my j, which I told you in the question, is less than 31. Then what we will do is we will say sum plus equal to 2 raised to the power j. This is the power function. But as we said, if the sum now exceeds the k value, then what we will do is we will set stop to 1. That is, we need to now stop. Stop is true. We don't need to take any more ones. And I will be decrementing the value that I added, which led to increasing the value of sum when compared to k. That is 2 raised to the power j. But if that does not lead to the value greater than k, then there is no issue. What I will do is I will just increment the length because that sum has successfully been added to my variable. Then for sure, whether or not it's a 0 or 1, whatever it is, the j value will be incremented because we need to keep on moving the powers of j, 2 raised to the power 0, then 1, and so on. And at the end, we return this answer. Let's run it. Commit. I hope the solution was clear to everyone. Please like, share, and subscribe the channel for more such Leetcode problem of the day solutions for a better and more clear understanding. Thank you.